እንዴት ናችሁ የተከበራችሁ የዩቲዩብ ቻናል ቤተሰቦች? ይህ የኢትዮ ዩኒቨርሲቲ ኤክስተርናል ሶሉሽን ሀብ የዩቲዩብ ቻናል ነው። በዚህ ዩቲዩብ ቻናል የተለያዩ የማውጫ ፈተና ጥያቄዎች ከነመልሶቻቸው ሙሉ ማብራሪያ ጋር የሚሰሩበት ዩቲዩብ ቻናል ነው። በዚህ ቻናል ላይ የምንለቀቀው ቪዲዮዎች አብዛኞቹ ለማውጫ ፈተና የሚጠቅሙ ፕላስ ለመማሪያም የሚጠቅሙ ቪዲዮዎች ናቸው። የመማሪያ ማቴሪያሎቹም በቪዲዮ መልክ እየሰራው በዚህ ዩቲዩብ ቻናል ላይ አስቀምጣለሁ። ለዚህ ዩቲዩብ ቻናል አዲስ ከሆናችሁ ይሄን ዩቲዩብ ቻናል ሰብስክራይብ በማድረግ የቻናል ቤተሰብ እንድትሆኑና በሰብስክሪፕሽን ቦክስ ውስጥ ኦል የምትል በተን አለች። እሷን በተን ኦን በማድረግ አዳዲስ በሚለቀቁ ቪዲዮዎች ላይ ኖቲፊኬሽን እንዲደርስ እንድታደርጉ ስታዩ ቪዲዮን ላይክ አድርጋችሁ እንድትጀምሩ ለጓደኞቻችሁ ሼር እንድታደርጉና በቪዲዮቹ ላይ ኮሜንት እንድታደርጉ ይላለኝ። ይህ ቪዲዮ በዚህ ቪዲዮ ላይ የ2015 የማውጫ ፈተና ጥያቄዎችን ስፔሻሊ ለሜካኒካል ምህንድስና ተማሪዎች የማውጫ ጥያቄ ፈተናዎችን አግኝቻለሁ። እነዚህ ጥያቄዎችን በአራት ፓርት ከፋፍዬ ነው የሚሰራው። የመጀመሪያ ፓርት አራውንድ 23 ጥያቄ አካባቢ ሰርቼ በዚህ ቪዲዮ አስቀምጫለሁ። ኔክስት ቪዲዮዎቹን ደግሞ ወደ 105 ጥያቄዎች አሉን። ጥያቄዎቹ የተደራረቡ ጥያቄዎችም አሉ። 105ቱንም በአራት ቦታ ከፋፍዬ ነው የሚሰራላችሁ። ስለዚህ ይሄን ቪዲዮ ጠቃሚ ነው ብላችሁ ካመናችሁ ለጓደኞቻችሁ ሼር እንድታደርጉና ሁሉም ተማሪዎች በማውጫ ፈተና ቢያንስ ፓስ ማርክ እንዲያመጡ እንድታደርጉ ይላለኝ። ምክንያቱም በዚህ ቪዲዮ ለሚሰሩ ጥያቄዎች በሙሉ ዲቴል ኤክስፕሌኔሽን ስላላቸው ተማሪዎቻችን ሊጠቅሙ ይችላሉ ብለን በማመን ነው የምናዘጋጀው ማዘጋጀው። ስለዚህ ይሄን ቪዲዮ ለብዙ ሰው ሼር እንድታደርጉና ለጓደኞቻችሁ ቪዲዮን ሪከመንድ እንድታደርጉ ይላለኝ። ይሄ ቪዲዮ ሲጀምሩ ላይክ አድርጋችሁ ሲጀምሩ ላይክ ስታደርጉ ቀጥታ ለጓደኞቻችሁ ስለሚደርስ ላይክ እንድታደርጉ ይላለኝ። ቻናሉንም ሰብስክራይብ አድርጋችሁ የቻናል ቤተሰብ እንድትሆኑ ይላለኝ። በዚህ ቪዲዮ ስፔሲፊካሊ የ2015 ኤግዚት ኤግዛም ጥያቄዎችን የሜካኒካል ምህንድስና ተማሪዎች ጥያቄዎችን ሰርቼላችኋለሁ። ሌላ ጥያቄ እንዲሰራላችሁ ኦር ከዚህም የተሻለ ጥያቄ ይሰራ ብላችሁ ያመናችሁትን ጥያቄ ካለ በስልክ ቀጥታ በስልክም በኢሜል አድሬስም ለኔ መላክ ትችላላችሁ። ኢሜል አድሬስና ስልክ ከየት ነው የምታገኙት? በዩቲዩብ ቻናል ውስጥ ገብታችሁ ኮንታክት ያመላለ በዛ ኮንታክት ላይ ኢሜልም አለ ስልክም አለ። ከዛ ቀጥታ ማግኘት ትችላላችሁ። ኦር በእያንዳንዱ ቪዲዮ ዲስክሪፕሽን ቦክስ ውስጥ የኔ ኮንታክት አድሬስ ስላለ ከዛ ማግኘት ትችላላችሁ።
Let's solve the question. Which one of the following fails to address the design requirement for shaft? A. Stepped shaft has better advantage over retaining gear on a specific position compared with retaining. B. A shaft can be designed with a spleen for effective power transmission to a gear. C. Any failure theory can be applied in designing a shaft regardless to the type of the load to be transmitted. D. Stress concentration areas are more severe to consider than bearing support areas. So from this, which one fails to address the design requirement during shaft designing? Therefore, here, as usual, to select the correct answer, we have to know each and every concepts which are discussed in each choice. And from this, after digesting these choices, we have to select the best one which addresses the design, the failure or which doesn't better describes the design requirement for shaft. So in A, let me go through each choices. In A, a steeper shaft has better advantage of retaining gear on a specific position compared to retaining. In this statement suggests a design consideration related to retaining gear on the shaft, and it addresses a specific aspect of shaft design, particularly when dealing with the gear. That means it correctly addresses the design requirement for the shaft. And B, a shaft can be designed with spleen for effective power transmission to a gear. That means in this, the statement highlights another design consideration, specifically using a spleen for power transmission during this shaft design. And it is valid consideration for ensuring effective power transmission between the components. So when we are connecting these shafts, we have to use this spleen. We have to use this spleen for effective power transmission. So this is also another consideration which directly or which correctly addresses the design requirement during shaft design. The other, any failure theory can be applied in designing a shaft regardless of the type of load to be transmitted. In this statement, it is problematic or it is incorrect. It is incorrect regarding this design requirement for shaft, because it implies that any failure theory can be applied without considering the type of load. In reality, the type of load, the type of load may be axial load, it may be torsional load, it may be bending. They are considering the type of load are significantly influence the design and the selection of material for a shaft. So when we are designing the shaft, we have to consider what type of load is going to be applied on the shaft. Which type of load is going to be developed on the shaft. So it significantly affects the selection of material. So different load may require different design approaches and considerations also. So when we design the shaft, when we are designing the shaft, we have to consider the type of load which is going to be developed or introduced on the shaft to select proper material for the shaft design. Therefore, this choice is not correct. The other is stress concentration area are more severe to consider than bearing support areas. This statement discusses stress concentration areas in comparison to bearing support areas. So here, both aspects are important in shaft design, but stating that stress concentration area are more severe could be an oversimplification. But both needs careful consideration during the design process. So in summary, the choice C is the one that falls short because it oversimplifies the application of failure theories, neglecting the importance of considering the specific type of load on the shaft or the specific type of load which is going to be induced or developed on the shaft. Therefore, the correct answer for this question is choice C. Choice C is the correct answer, which fails to address design requirement for shaft. So this is the correct answer. Question number 2. Which of the following is correct in the study of fluid kinematics? A streamline consists of a bundle of streamlines. B, a streamline is a curve that is everywhere tangent to the instantaneous local velocity vector. C, a path line is the locus of fluid particles that have passed sequentially through a prescribed point in the flow. D, a streamline is the actual path traveled by an individual fluid particle over some time period. So from this, which one is correct in the study of fluid kinematics? So certainly let's discuss the explanation for each option from the perspective of fluid kinematics. In a streamline consists of a bundle of streamlines. In this statement is not accurate. This is not accurate because a streamline is an imaginary line that is tangent to the velocity vector at every point in the flow field, and it doesn't consist of a bundle. Each streamline represents the path that a fluid element would follow in steady state conditions. So this streamline helps to visualize the flow patterns. So these streamlines are helpful to visualize the flow patterns, and they are an imaginary line that is tangent to the velocity vector at every point in the fluid flow. So this streamline doesn't consist of a bundle, but in the choice it says this streamline consists of a bundle of streamlines. So it is incorrect or not accurate choice. The other is a streamline line is a curve that is everywhere tangent to the instantaneous local velocity vector. This statement is correct. This is accurate or correct or perfect statement. As a streamline is a curve that at every point it is tangent to the velocity of the fluid at the particular instant, and it provides a snapshot of the flow field at a specific moment in a time. And the direction of the streamline at any point represents the direction of the velocity vector at that point. So this streamline is a curve that is everywhere tangent to the instantaneous local velocity vector. This is the correct statement. In C, a path line is the locus of the locus of fluid particles that are passed sequentially through a prescribed point in the fluid. This statement is also not correct because a path line is the actual path traveled by an individual fluid particle as it moves through the flow. It is the representation of the motion of a specific fluid particle over time, and unlike streamlines, path lines show the history of the motion of the particle in the flow. So from this, when we say this path line, it represents the actual path traced by a fluid particle over time. But in this case, it says that the path line is the locus of fluid particles that are passed sequentially through a prescribed point in the flow. This is also the wrong statement. In D, it says the streamline is the actual path traveled by an individual fluid particle over some time period. So the actual path traveled by an individual fluid particle over time is more accurately described by the path line rather than that of streamline. So this is the false statement also. Therefore, in summary, when we come to this streamline, it represents an instantaneous flow pattern at a specific moment. When we come to path line, it represents the actual path traced by a fluid particle over time. Therefore, the correct option for this question is choice B. This choice B is correct answer because the streamline is a curve that is everywhere tangent to the instantaneous local velocity vector. When we see the others, they are problematic or have some error. Question number 3. Which one of the following is inspect about grouping of machine in plant design? Which one of the following is inspect about grouping of machine in plant design? A machine to either other item of equipment must be placed at the point demanded by the sequence of operation. B, materials may be fed where they are required for assembly but not necessarily at one point. C, all the operation including assembly, testing, packing must be included in the line. D, there should be a point where one line crosses another line. So to answer also this question, we have to know what does mean this grouping a machine. We have different form of grouping a machine during this facility layout. So we have different forms of grouping machines. This is regarding that plant layout. So when we say plant layout, it is the systematic arrangement of machines and other resources within the plant in order to ensure effective use of space that we have and resource that we have to ensure the productivity of the overall organization. So regarding this, grouping machine is one of the key aspects of that the plant layout. And in this question, we are asked to answer the question regarding this grouping of a machine in plant design. So to answer this, here let me discuss one by one. When we see this option A, it emphasizes the importance of placing machine to ease the sequence of operations, which is valid. It is correct. However, it doesn't address all the operation, including assembly, testing, and packing. When we are grouping the machine, we have to consider this the aspects like this assembly, testing, as well as packing. So to do this, we have different principles regarding this grouping the machines on the plant layout. So we have to consider this assembling procedure, testing procedure, packing procedure, in addition to the operation of this value-adding process on the product parts. So the first case, choice A, emphasizes only the importance of placing machine to ease the sequence of the operation. It doesn't address all the operations, including assembly, testing, and packing. So from this point of view, this is incorrect. This is incorrect. The next on B, it suggests that material may be fed where they are required for assembly, but it doesn't explicitly mention the inclusion of all operation in the line. So it fails due to this. In C, it is correct. This statement as C is correct because it suggests or it emphasizes all the operations, including assembly, testing, and packing. It should be included in the production line. So the process of assembly, the production of testing as well as packing must be or should be included in the production line. So this ensures a comprehensive approach to manufacturing, covering all necessary steps in the sequential manner. So this in C it is correct because it includes all the operations, including this assembly, testing, and packing, in addition to manufacturing or value-adding process. In D, it mentions a point where one line cross another, which may be consideration in the plant layout, but doesn't explicitly address the inclusion of all other operations also. The crossing of lines or production line may be considered when we are grouping the machines, but this option or this choice doesn't addresses the overall mechanism or process which are included in the production line. So the correct answer from this explanation is this C, all the machines or all the operation including assembly, testing, packing must be included in the line. So this is the correct answer from this point of view, grouping of a machine during plant design. So during plant design, we have to consider all the operations, including assembly, testing, as well as packing operations, which must be included in the plant layout or on the plant line or layout design. Next, select the factor which is not a requirement in metal forming process using bending. Select the factor which is not requirement in metal forming process using bending. A, required strip length. B, material thickness. C, material conductivity. D, minimum radius of the bend. So from this, which one is not requirement during metal forming process using bending operation? So to select this, also we have to explain the terms, the concepts. When we say this required strip length, this is the length of a metal strip needed for bending is indeed a requirement. So this required strip length is the length of the metal strip needed for bending, which is the best requirement, and the length is determined based on the factors such as the angle of bend, the radius of the bend, and the material's properties also. So this is the requirement or the thing that we have to consider during this metal forming process by using bending. The other is material thickness. The thickness of the material being bent is a critical parameter in the bending process. So we have to consider this the thickness of the material. We have to consider the thickness of the material during bending process because it plays a crucial role when we perform or we form metals using bending operation. So when we say this, the thickness of material may affect the bending operation or the metal forming process operation by using bending process. The other is the material conductivity. When we say this, the material conductivity is generally not a primary consideration in the bending process. For bending process, we not primarily consider this material conductivity. We may not consider this material conductivity. While this electrical conductivity may be relevant in certain application, and it is not a standard requirement for the bending process when we are forming the material by using this bending operation. And D, the minimum radius of the bend. This is very crucial. When we say the minimum radius of the bend, it is radius of the bend, which is crucial factor in the bending process, and it determines how sharp or gradual the bend will be and affect the overall integrity of the material. So this part. This is also crucial. This is also crucial when we are forming the metal or metal forming process by using this bending. But this material conductivity may not be primarily considered, or it may not be a factor when we are forming this metal forming process by using the bending operation. Next, in closed moving boundary system, a positive change in internal energy decreases when A, heat is added and work is done on the system. B, heat is added and work is done by the system. C, heat is removed and work is done by the system. D, heat is added and work done is 0. So when we say in closed moving boundary system, a positive change in internal energy decrease when heat is added and work is done on the system. B, heat is added and work is done by the system. C, heat is removed and work is done by the system. And D, heat is added and work done is 0. So from this, which one best shows the positive change in internal energy on closed moving boundary system? So in this, certainly let me go through each choice and describe the implication in the context of closed moving boundary system. So in this, in A, heat is added and work is done on the system. In this choice suggests that heat is being added to the system, which would tend to increase the internal energy. When we add heat, we are increasing the internal energy. And however, work is being done on the system, and if this work is significant enough to overcome the heat added, it could result in net decrease in internal energy. In B, heat is added and work is done by the system, and that means heat is added to the system, which tend to increase the internal energy. When we are adding heat to the system, we are increasing the internal energy. So additionally, the system is doing work, which can also contribute to an increase in internal energy. The system is doing work, which can also contribute to an increase in internal energy. So the system is doing work as well as we are adding energy. And C, heat is removed and work is done by the system. This choice involves removing heat from the system, which tend to decrease the internal energy. And the system is doing work, and if this work is significant enough, it could contribute to a net decrease in internal energy also. And in D, heat is added and work done is 0. This scenario suggests that heat is added to the system, which would tend to increase the internal energy. However, if no work is done by the system, the overall effect would be an increase in internal energy also. So from this explanation, this is the closed moving boundary system. In closed moving boundary system, a positive change in internal energy decrease when we say this, heat is removed and work is done by the system. This choice involves removing heat from the system, which tend to decrease the internal energy. And the system is doing work, and if this work is significant enough, it could contribute to a net decrease in internal energy. Okay, so the correct answer for this question is choice C. If heat is removed and work is done by the system, this shows the positive change in internal energy. Next, what is the first step in project planning? A, inspect the deliverables. B, establish the objective and scope. C, determine the budget. D, determine project constraints. So this, to answer this is also from industrial management and engineering economic part. And we have the functions of management, and from that function, planning is the first one. So when we are planning a project, we have numerous steps. And from this, which one is the first step? I explain this each and every parties. In choice A, inspecting the deliverables. This is usually done after the objective and the scope are defined as deliverables are the outcome of the project. So when we say deliverables, they are the outcomes. So before them, we have to do some other steps. Since these deliverables are the output of the project. And in B, it says establish the objective and the scope. This establishing the object and the scope is the first step when we are planning the project. This involves defining the purpose of the project, its goal, and the specific tasks that need to be accomplished during each step. And it sets the foundation for the entire project. When we are establishing the object and the scope, it sets the foundation for the entire project. So this is the correct step, the correct answer for this question, the first step in project planning. When we go to the C, determine the budget. Budgeting is an important aspect, as we know, but it is usually developed based on the project's objective and the scope. So to determine the budget, we have to know the objectives and the scope also. If the objective is not clear or not set well, and if the scope is not known, we cannot set the budget. We cannot determine exact budget also. So this is the, but determining the budget is the important part, but it is not the first step in project planning. The other is determining project constraints. This determining project constraints is also identifying constraints, which is essential, but it is often done after understanding the objective and the scope to ensure that the project can be realistically accomplished within given constraints. So to determine the project constraint also, we have to know the object as well as the scope. We have to set the objective as well as the scope of the project. So the correct answer for this question is this B. Establishing the objective and the scope is the first step in project planning. But the others are essential steps. The others are essential steps that we have to consider or we have to perform during project planning. But in this question, we are asked to determine, or we are asked to answer what is the first step, or which one of this the listed one is the first step in project planning. So the correct answer is establishing the objective and the scope for a specific project. Other question: an open system is one in which A, mass doesn't cross boundary of the system through energy, might do so. B, mass crosses the boundary but not the energy. C, neither mass nor energy cross the boundary of the system. D, both energy and mass cross the boundary of the system. So from this explanation, which one best explains open system? So to answer also this question, we have to know what does mean open system. As I have provided on the previous video, I think, on engineering thermodynamic part, what does open system and what does closed system means. When we say this open system, it is the system at which both mass and energy can be exchanged with the surroundings. So the system is open to the surrounding, and due to this, the both mass and energy can be exchanged within the surrounding. And this means that matter can enter or leave the system, and energy can be transferred across the system boundaries. That means when there is matter entering as well as leaving the system, the energy can be transferred across the system boundaries. So some of the examples of this open system include many biological and industrial processes where both mass and energy transfer are significant. So in this case here, when we say open system, it means that both energy and mass across the boundary. So this is the correct answer. Next, which of the following statements is incorrectly related with mechanical spring? Which of the following statement is incorrectly related with mechanical spring, which are vital in machine design for their effective system control mechanism? A, designing a spring for a system controlling operation shall consider the applied load as a variable load. B, designing of a spring shall consider both the allowable strength and stiffness with that of the maximum induced stress and deformation. C, although the loading condition for different spring types are different, the stress induced in the spring is affected with the end or joining condition. D, designing consideration for coil spring can be totally adopted for flat leaf spring design. So from this, when we're designing a spring for a system controlling operation shall consider the applied load as variable load. This is correct. Because we have to consider this load, this applied load as variable load when we are designing springs. And the other is design of a spring shall consider both the allowable strength and the stiffness. The stiffness that of the maximum induced stress and deformation. This is also the correct statement that we have to consider during this mechanical spring design. The other is also the loading condition for different spring type are different. The stress induced in the spring is affected with the end joint. the end or joining condition, this is also the correct statement. But in D, we have designing consideration for coil spring can be totally adopted for flat leaf spring consideration. This is wrong. This is wrong. We cannot apply designing consideration for coil spring totally for flat leaf springs. So when we say this, coil spring and flat leaf spring have different geometries and loading carrying mechanisms. Design consideration for one type of spring may not be directly applicable to the other. And coil spring typically operate by axial compression or extension, while flat leaf spring function by bending. So the factor influencing stress, deflection, and performance differ between these two types of springs. Therefore, each type of spring requires a specific design consideration based on its geometry, loading condition, and intended applications. Therefore, the option D is incorrect, as designing consideration for coil spring cannot be entirely adopted for flat leaf spring design without accounting for the unique characteristics of each type. So this D is incorrect regarding this mechanical spring design. The other here, consider heat transfer through the wall of a house as an example. And if the condition inside the house and the outdoor remains constant for several hours, the mode of heat transfer that will be employed for solving this problem is A, steady state conduction heat transfer, B, transient conduction heat transfer, C, transient convection heat transfer, D, steady state convection heat transfer. When we say this steady state conduction, it refers to the situation where the temperature distribution within the system doesn't change with time. So here, when we say steady state conduction, this means it refers to the situation where the temperature distribution within the system doesn't change with time. And in this case, the temperature inside the house and outdoor are constant for several times. That indicate the steady state condition. So when we say this conduction, it is the primary mode of heat transfer through the wall of the house, as there are no significant change in temperature with time. When we say transient conduction, that means on option B, it would apply if there were significant change in the temperature over time. When we say transient conduction, or choice B could be or would be applied if there were significant change in temperature over time. But in this scenario, in this given scenario, it describes that it indicates the steady state conditions because there is no variation of the system or temperature variation within the system with the time. So in this case, the temperature inside the house and the outdoor are constant for several times. So there is no temperature change. That means this transient conduction, which is not applicable for this situation because it is applicable if there is temperature change with time. When we say convection at option C and D, we have given option C and D convection. So typically this involves fluid flow and is not primarily more considered when heat is transferred through the solid wall of the house. Therefore, the correct answer for this question is choice A, steady state conduction heat transfer. This is the correct answer. Next, a measurement system can be developed using A, digital to analog converter if the measured quantity to be recorded, B, transducers which are usually categorized under electrical transducers, C, transducers that support to quantify the physical variable without changing the best fit of the signal to signal conditioning, D, signal processors that support to condition signal before the signal sent to the recorder or displayer. This is what the mechatronics part from this. It can be this. The measurement system can be developed by using signal process that support to condition signals before the signal sent to the recorder or displayer. This is the correct answer because here when we say this, signal processing is a crucial component of measurement system, and these signal processors are used to condition signals which may involve amplification, filtering, or other operations to ensure accurate and reliable measurements. So when you say this digital to analog converters at option A, they are used when there is a need to convert digital signal to analog signal, but it may not be necessarily for all measurement types. And at B, transducers, when you say this, they are devices that convert one form of energy into another, and they play a key role or crucial role in measuring physical variables. However, these transducers are not limited to electrical transducers. Therefore, the statement which is this case in choice D is most comprehensive and relevant choice for developing a measurement system, as signal processors play a crucial role in conditioning signal before they are recorded or displayed. Therefore, the measurement system can be developed using the signal processor that support to condition signals before the signal sent to the recorder or display. D is the correct answer. In an ideal vapor compression refrigeration cycle, the constant pressure, heat absorption, and heat rejection occurs at A, compressor and evaporator respectively, B, evaporator and condenser respectively, C, at condenser and evaporator respectively, D, evaporator and compressor respectively. Usually this vapor compression cycle is performed in four components. There is compressor, there is condenser, expansion valve, which is usually called throttle valve, and there is evaporator. And in ideal vapor compression cycle, the system executing the cycle undergoes a series of four processes. So here we have eccentric compression. In the first, there is eccentric compression, which is usually called compression in the piston compressor. And this, in this, there is circulating refrigerant enter the compressor as low pressure vapor at or it's low below the temperature of the refrigerator interior valve, and the gaseous medium is compressed adiabatically from state to state. There is four states, and in the next there is isobaric heat rejection. Usually, there is isobaric heat rejection process, and in this process is performed usually in condenser. Usually, this is performed in condenser. And the other is there is isobaric heat addition. Isobaric heat addition process. Usually this is performed in evaporator part. And there is isenthalpic process also, which is expansion in expansion valve. There is expansion in expansion valve. Therefore, in this case, in isobaric heat rejection, this heat is rejected through condenser, and heat is absorbed through evaporator. Therefore, from this question, in the vapor compression refrigeration cycle, the refrigerant undergoes a series of processes to absorb heat from a low temperature space. That means from evaporator, and rejects heat to the high temperature space, that is condenser. So when you say this evaporator, it is where the refrigerant absorbs heat from the space being cooled, and is the process ideally occurs at the constant pressure. And when we say this condenser, it is the refrigerant rejects heat to the surrounding, and this process also ideally occurs at the constant pressure. Therefore, the correct answer for this question is choice B. Choice B is the correct answer for this specific question. So in ideal vapor compression refrigeration cycle, the constant pressure, heat absorption occurs at the evaporator. That means heat addition is observed at this evaporator part, and heat is rejected through the condenser part. So heat rejection is at condenser, and heat absorption is at evaporator. So B is the correct answer. Next question. When performing coupling alignment, the first activity that must be conducted is A. Check coupling spacing, B. Check run out, C. Verify parallel misalignment, D. Verify angular misalignment. So which of this activity will be or could be performed first when we are coupling, or when we are doing or performing coupling alignment? So here we know that when performing this coupling alignment, we have to do a series of activities. Therefore, some of them are here listed below, but which one comes first? And A, when we say this check coupling spacing, when we say this checking coupling spacing, this involves ensuring that the distance between the coupling hubs is appropriate, whether the distance between the two coupling hubs are, or between coupling hubs is appropriate or not. So this is due to incorrect spacing can lead to misalignment issues, but typically other aspects like run out are checked first. So we have to check this the run out rather than this checking run out is must come before this checking coupling spacing. But this is the basic part or the basic activity that we have to consider or that affect the efficiency or the effectiveness of this coupling alignment. When we say this check run out or run out refer to the eccentricity or wobbling of the rotating element, and in this context of coupling alignment, check run out involves making sure that both shafts are rotating in true circular motion without excessive eccentricity. And if there is a significant run out, it can affect the alignment of the coupled shafts. So this is one of the activities which can be performed or which should be performed before any other activities. When we come to this verifying parallel misalignments, these parallel misalignments occur when the shafts are not aligned in a straight line. And verifying this parallel misalignment involves checking if the two shafts are parallel to each other or not. And if they are not, it can lead to additional stress on the bearing and misalignment issues. So this is also another issue that we have to emphasize when we are performing coupling alignment. But it couldn't come first, or it couldn't be performed first, because we have to perform other activity which could come first when we are performing this coupling alignment. In D, verifying angular misalignment, when we say this, it occurs when the axes of the two shafts are not in the same straight line. And verifying this angular misalignment involves checking if the shafts are at the correct angle related to each other. And this angular misalignment can lead to increased wear on the components and reduce efficiency also. So while each of these factors is crucial in coupling alignment, checking the runout is often considered the first activity because it addresses the immediate rotational issues and helps ensure that the rotating elements are moving in the stable and true circular motion before addressing parallel or angular misalignments. And if there is excessive runout, it may need to be corrected before further alignment activities are performed. Therefore, the correct answer for this question is checking the runout or check a runout. But these all options or these all concepts are very crucial when we are performing this coupling activity. But this check runout must come first. The other, which of the following is an impulse turbine? A. Propeller turbine, B. Pelton turbine, C. Francis turbine, D. Kaplan turbine. So which one of this is an impulse turbine? So here we have types of turbine. We have learned that within these different subjects we have tried to see, or we have learned types of turbine, which is impulse or reaction turbines. So from these we are asked to differentiate which one is impulse turbine. So whether propeller, Pelton, Francis, or Kaplan. So when we say this propeller turbine, it is typically a type of Kaplan turbine, which is a reaction turbine. This propeller turbine it is a reaction turbine. And when we go to this Pelton turbine is an impulse turbine that the pressure drop of the fluid, usually water, occurs as it impacts the turbine blades. In the case of this Pelton turbine, water is directed onto spoon-shaped buckets mounted on the perimeter of the wheel, and the water jet impinges on the bucket, generating a high-velocity impulse that drives the turbine. When it comes to the Francis turbine, it is a reaction turbine also. This Francis turbine is it's a reaction type turbine that operates with both radial and axial flow. And this Kaplan turbine it is a type of reaction turbine also with adjustable blade to accommodate different flow conditions. So this one is one of the reaction turbine. This is also another reaction turbine. This is a reaction turbine rather than impulse turbine. This is also a reaction turbine. This is also a reaction turbine. So the correct answer is this Pelton turbine, which is impulse turbine from the list. Which one of the following statement describes the design process of a machine element? A. A design process is an iterative decision-making process. B. Decision in design process can be made intuitively. C. A detailed drawing is the output of the embodiment process. B. The design process starts from concept synthesizing process. So from this, which of the following this statement describes design process of a machine? Okay, so when we are designing a machine, we have a series of processes, and certainly let's break down each statement and let me see. Let me try some of the discussion parts for each choice. In A, when we say a design process is an iterative decision-making process, this statement highlights a fundamental aspect of the design process. When we say this design is the design of the machine, it is rarely a linear path. Instead, it often involves a series of iterations. So engineers and designers make decisions, evaluate the design, make adjustments, and repeat this process until they arrive at a satisfactory solution. An iterative design allows for refinement and improvement as the design progresses. So in this case, this is the correct part, which describes the design process of the machine element. In the B, when you say decision in the design process can be made attentively, this statement suggests that intuition or the designers get feeling and experience, and which can play a role in decision-making process. While engineering design often involves rigorous analysis and calculations, experienced designers may also really rely on intuitions to guide certain decisions, especially when faced with both complex or novel problems. So this in B, decision in design process can be made intuitively. That means that it is this statement suggests the intuition or the designers get gut feeling and experience, which can play a role in decision-making process also. But it doesn't directly state the design process of a machine, but it describes the intuition or the designer's gut feeling and experience, which can also apply the decision-making process. Okay, in D, we'll see a detailed drawing is the output of the embodiment process. This embodiment process in the design involves refining the chosen concept into a more detailed and concrete form. Detailed drawing are a common output of this stage, and this drawing provides specific information about dimensions, tolerance, materials, and other details needed for the machine element. And indeed, the design process starts from the concept synthesis process. This is the concept synthesis is the stage where various ideas and concepts are generated and evaluated. And this statement implies that the decision process or the design process begins with generation of different concepts or ideas. Once concepts are synthesized, they undergo further evaluation and refinement in subsequent stage of the design. So when I summarize this, design process is iterative and involves making decisions at various stages, which utilize both analytical approach and intuitions, and it starts with the synthesis of concepts and progress through embodiment, where detailed drawings are produced to guide manufacturing. Therefore, it directly shows that this design process is an iterative decision-making process. This is the best, which shows the best statement which describes design process of a machine element. And these all are, the others are, the outputs or the supportive part of this concept. Next question, which one of the following statements is incorrect about dynamic balancing? Which of the following statement is incorrect about dynamic balancing? It is possible for a system to be single plane balanced but not be dynamically balanced. B, the dynamic balance requires the sum of all forces and moment must be zero. C, to correct dynamic unbalance requires either adding or removing the right amount of mass at the proper angular location into correction planes separated by one distance along the shaft. D, conducting a dynamic balance before a system single plane balance is a good practice. So which of this is incorrect about dynamic balancing? Therefore, to answer this also, we have to discuss each choices, or we have to discuss this, what does dynamic balancing mean? What does dynamic balancing mean? So when I get into this, the first choice A, it is possible for a system to be single plane balanced but not to be dynamically balanced. This statement is incorrect because this single plane balancing is a subset of dynamic balancing. Here, this statement is incorrect because it is the single plane balancing is a subset of dynamic balancing, and if the system, or if a system is single plane balanced, it is also dynamically balanced. And single plane balancing refers to balancing the mass in one plane only, and typically by adding or removing mass in a single correction plane. So in dynamic balancing, on the other hand, it involves balancing the entire system in multiple planes, considering both mass and angular positions. Therefore, a system that is a single plane balance is inherently dynamically balanced in that particular plane. A is incorrect. So B, the dynamic balance requires the sum of all force and moment must be zero. So this statement is generally correct or accurate. When you say dynamic balance, it involves ensuring that the sum of all force and moment is zero, which means there is no net force or moment acting on the system. And achieving dynamic balance helps minimizing vibration and ensures smooth operation of this rotational machinery or rotating machinery. So B, which is correct about this dynamic balancing. And C, it says this to correct dynamic unbalance requires either adding or removing the right amount of mass at the proper angular location in two correction planes separated by some distance along the shaft. This statement is also correct. Generally, it is correct or it is accurate. When correcting dynamic unbalance, it involves adding or removing mass at a specific angular position in two or more correction planes along the shaft. And the goal is, or the goal of, or the target of doing this is to achieve balance not only in a single plane but dynamically throughout the entire system. So this is C is also the correct statement regarding dynamic balance. And D, there is conducting a dynamic balance before a system single plane balance is a good practice. This statement is generally also correct. So it is often considered good practice to perform a dynamic balance before a single plane balance. So dynamic balance provides a more comprehensive assessment of the system's balance by considering mass distribution in multiple planes. So once dynamic balance is achieved, a single plane balance can be performed if necessary for specific application. So when I summarize this, in summary, dynamic balancing is a more comprehensive approach that includes single plane balancing and ensure balance in multiple planes, and the correction of dynamic unbalance involves adding or removing mass at a specific angular position in multiple correction planes to achieve overall balance in the system. Therefore, the statement in choice A is incorrect because of a system is single plane balance is also dynamically balancing. Dynamic balance involves not only balancing the mass in a single plane, but also ensuring that the mass distribution is correct with respect to its angular position around the entire rotor. So a system that is single plane balance is by definition also dynamically balanced. So this is at A. It is incorrect regarding this dynamic balance. When you say a system which is balanced in a single plane, it is also dynamically balanced. So this is incorrect because it says it is possible for a system to be single plane balanced but not dynamic balance. This is not correct or incorrect regarding dynamic balancing. So this is correct. When you say this dynamic balance requires the sum of all force and moment must be zero, this is correct. The correct dynamic unbalance requires either adding or removing the right amount of mass at the proper angular position. This is also correct, and the D also is correct. So the incorrect statement, which is regarding this dynamic unbalance or dynamic balancing, is at A, which is it is possible for a system to be single plane balance but not be dynamically balanced. This is incorrect. When we say this, if a system is balanced in single plane, it is also balanced at dynamic plane also. So this is incorrect. There is repetition of questions. So it is in an ideal vapor compression or bridging cycle, the constant pressure, heat absorption, and heat rejection occur at at the evaporator and at the condenser respectively. So there is a repetition of questions also. Which statement correctly describes the consideration of safety device to be applied in conveyor equipment usage? A. Safety device will enhance the efficiency of the conveying operation. B. Safety device will support to sample the material being conveyed or discharged. C. Safety device will support to screen foreign materials used to control the motion of the material to be conveyed. The safety device are used to control the conveyor operation to minimize hazard in working area. So from this, which statement correctly describes this the safety device to be applied in conveyor equipment usage. Therefore, when we say this safety device, we have to know what does this safety device mean. What does safety device mean? Therefore, in A, so a safety device will enhance the efficiency of the conveying operation. This statement is, or this expression is not generally not accurate, because the primary purpose of the safety device in a conveyor equipment is to ensure the safety of workers and prevent accidents. So when you say this safety device, it is usually primarily set a goal to keep or to make the operators safe, to keep the operators safe during the operation. So the primary purpose of this safety device is, or in conveyor equipment, is to ensure the safety of workers and prevent accidents. And while they contribute to a safer working environment, their main focus is not to enhance the efficiency of the conveying operations. When we say this, safety measures may involve features such as emergency stop, guards, and interlocks to protect workers from potential hazards. So from this, the first one is not accurate. The other is safety device will support to sample the material being conveyed or discharged. This statement is also not accurate or not correct, because these safety devices are typically not designed for sampling materials. The sampling is a separate process that is usually carried out from quality control or other analysis purposes, and these safety devices are implemented to control the operation of the conveyor and prevent different accidents or injuries during the operation. And see, it says this safety device will support a screen for a material used to control the motion of material to be conveyed. This statement is also not correct in this context of this safety device. So screening for a material is the function related to design and operation of the conveyor itself, not specifically to safety device. So when we say the safety device, they focus on preventing accidents and ensuring safe operations, while screening for a material is more related to the functionality of this conveying system or conveyor system. And indeed, safety devices are used to control the conveyor operation to minimize hazard in the working area. This statement is accurate or correct from the objective of this using safety devices. So safety devices in a conveyor equipment are indeed used to control the operation of the conveyor system to minimize hazards in the working area. And some of the examples of this it includes emergency stop, pull cord, guards, interlocks, and sensors that can detect unsafe conditions and trigger a shutdown or other protective measure to prevent accidents and injuries. So in summary, the primary purpose of this safety device in conveyor equipment is to ensure the safety of personnel and minimize hazard in the working area, not to enhance efficiency, sample material, or screen for materials. So choice D is the correct answer regarding this safety device to be applied in conveyor system. The other, heat transfer through a fluid is A, by conducting in the presence of bulk fluid motion and by convection in the absence of it. E, by convection in the presence of bulk fluid motion and by conduction in the absence of it. C, by convection and conducting in the absence of bulk fluid motion. D, by convection and conducting in the presence of bulk fluid motion. So from this, which one is true regarding this heat transfer through fluid? Certainly, let me discuss some points on each option. In A, it says by conduction in the presence of bulk fluid motion and by convection in the absence of it. This statement is not accurate. And in the presence of bulk fluid motion,
heat transfer is primarily through convection. If there is bulk fluid motion, heat transfer is primarily through convection, not conduction. And conduction is more relevant when there is minimal fluid motion. There is minimal fluid motion. So due to this statement A is not correct. The other is by convection in the presence of bulk motion, fluid motion, and by conduction in the absence of it. This statement is correct. This statement is correct or accurate, because in the presence of bulk fluid motion, which is convection, heat transfer occurs through the movement of fluid particles, and in the absence of significant bulk fluid motion, heat transfer takes place through conduction, which involves the transfer of heat through direct microscopic interaction between adjacent fluid particles. And when we come to the next and see, by convection and conduction in the absence of bulk motion. In the absence of bulk fluid motion, conduction becomes more prominent, and however, convection may still occur to some extent due to natural convection, where it is transferred through Beyoncean driver fluid motions. And in D, by convection and conduction in the presence of bulk motion. In summary, the correct option is this B, heat transfer through a fluid primarily by convection in the presence of bulk fluid motion, and by conduction in the absence of it. And the presence or absence of bulk fluid motion plays a crucial role in determining the dominant mode of heat transfer in a given scenario. The correct answer for this question is choice B. This heat transfer through a fluid primarily occurs by convection when there is bulk fluid motion, and by conduction when there is no significant bulk motion. Convection involves the transfer of heat through the movement of fluid particles, while conduction occurs through direct microscopic interaction between adjacent fluid particles. Therefore, B is the correct answer for this question. The next image, this is also the repetition. This is also the measurement system can be developed by using. This is the correct answer. A stoichiometric air-fuel ratio is A. The ratio used at full rated parameters. B. Rich mixture for overloads. C. Lean mixture. D. Chemically correct mixture. So what does this stoichiometric air-fuel ratio? Let me explain this certainly. So when we say this, the ratio used at full rated parameter at air, this option is not accurate, since the air-fuel ratio used at the full rated parameter can vary depending on the engine and its operating condition, and these stoichiometric conditions are not necessarily specific to the full rated parameters. Rather, they represent the chemically correct mixture for combustions. And in B, rich mixture for overloads. And this rich mixture contains an excess of fuel compared to the stoichiometric ratio, and this option is also incorrect because the stoichiometric mixture is chemically correct for combustion, and in contrast, a rich mixture or more fuel is often used for overload or high power demands, but it may result in incomplete combustion and increased emissions. And in C, lean mixture. A lean mixture contains less fuel compared to the stoichiometric ratio. This option is also incorrect because the stoichiometric mixture is not a lean mixture. When we say this lean mixture or less fuel, they are sometimes used for fuel efficiency, but they may not lead to higher combustion temperature and increase nitrogen oxide emissions. And when we come to D, chemically correct mixture, this is the correct option. When we say this is stoichiometric air-fuel ratio, it is the chemically correct mixture that allows complete combustion. In summary, the stoichiometric fuel ratio is the chemically correct mixture of combustion, and it is represented by this the concept which is expressed in the choice D, which is the chemically correct mixture of air and fuel that allows complete combustion with no excess air or fuel remaining after the combustion process. So this is D is the correct answer. When you say this is stoichiometric air-fuel ratio, it is the chemically correct mixture.
Next, which one of the following is not the function of fuel injection system for compression ignition engines? A, to meter or to measure the correct quantity of fuel to be injected. B, to time the fuel injection. C, properly distribute the fuel in the combustion chamber. D, none of the above. So from this, which one is not the function of this fuel injection system for compression ignition engines? At A, to meter or to measure the correct quantity of fuel to be injected. This function involves precisely controlling the amount of fuel delivered to each cylinder for combustion, and it is crucial for engine performance, efficiency, and emission control. So this is one of the function of fuel injection system. And in B, there is time and fuel injection. There is time and fuel injection. It says time the fuel injection. Time the fuel injection. So timing the fuel injection ensures that the fuel is injected into the combustion chamber at the optimal moment in the engine cycle. So proper timing is essential for efficient combustion and engine performance. So this is also the other function for the fuel injection system. In C, there is properly distribute the fuel in the combustion chamber. The fuel injection system must ensure that the fuel is evenly distributed within the combustion chamber, and this distribution affects the combustion efficiency and emission also. So from this, the correct answer is D, none, as all the mentioned functions are indeed function of the fuel injection system for compression ignition engines. So this D is the correct answer.
በዚህ ቪዲዮ ወደ 22 ጥያቄዎች ሰርቻለሁ። ቀጥሎ ባለው ቪዲዮዎቹ ላይ ቀጣይ ፓርቶችን ወደ 105 ጥያቄ እንዳለን ነገሮችን ነበረ። ከ105 ጥያቄዎቹ አሁን ወደ 22 ጥያቄ ነው የሰራሁት። የተደጋገሙ ጥያቄዎች ስላሉ የተደጋገሙ ጥያቄዎችን እያወጣሁ አዲስ ጥያቄዎችን ተሰብስቤ እየከተትኩ 105ቱንም ጥያቄ ከሙሉ ማብራሪያ ጋር እሰራላችኋለሁ። በዚህ ቪዲዮ ወደ 22 ጥያቄ ነው የሰራሁት። ከ22 ቀጥሎ ያለው ጥያቄውን ደግሞ ቀጣይ ቪዲዮዎቹ ላይ ይዤበታለሁ። በቀጣይ በቅርብ ምክንያቱም ፈተናው ስለደረሰ በአንድ ቀን ውስጥ ሌላ ቪዲዮ አፕሎድ አደርጋለሁ። እስከዛ በዚህ ዩቲዩብ ቻናል ላይ የሚለቀቁ ቪዲዮዎች ሁሉ እያያችሁና ለጓደኞቻችሁ ሼር እያደረጋችሁ እንድትቆዩ በቪዲዮ ላይ ኮሜንት እንድትጽፉና ቻናሉን አዲስ ከሆናችሁ ለቻናሉ ሰብስክራይብ እንድታደርጉ እላለሁ። በቀጣይ ቪዲዮ እስከምንገናኝ ደህና